In the last videos, we discussed about the earth. We have mentioned different aspects of earth. Now we are going to extrapolate our vision. That is, we are going to the next astronomical system, which is the solar system. The sun, the revolving planet, the asteroids, comets, meteors, etc. constitute the solar system. In this chapter, first of all, we will discuss about some of the general aspects of the sun. Then we will discuss about the structure of the sun. Remember that the structure of the sun means it is only about the visible part of the sun, the atmosphere of the sun, not about the core of the sun. Because still studies are going on to reveal the structure of the sun. So we will discuss only about the atmosphere of the sun, but that is what we can see during the day as well as during the eclipses. And after we will discuss about the planets, the 8 planets which revolves around the sun, and one of the planet which we are already discussed in deep, that is the earth. Now we will discuss about a brief discussion about the other 7 planets, and also we will have a look into the other interesting astronomical phenomena like comets, asteroids, meteor showers, etc. So first of all, let's start with the center point of the solar system, the sun. As you all know that sun is a self-luminous, intensely hot, vast gaseous globe. This is typically a star, which is a typical star among the 10 raised to 11 stars of our galaxy, and sun is the nearest one of the stars, or nearest one to us. Other stars appear as mere points of light because they are so distant objects in comparison with the sun. To understand the distance between the sun and the next nearest star to us, just look into the time taken by the light ray or light to reach from that star to the earth. By calculation, we can see that the light from the sun takes 8 minutes to reach on earth. As you know the velocity of light and also the distance of the sun and earth, so from that fact you can calculate the time taken by the light to reach on earth from the sun. But at the same time, if you consider the time taken by the light from the next nearest star, that is the Alpha Centauri, Proxima Centauri A, B and Proxima Centauri, Alpha Centauri A, B and Proxima Centauri. This is a triple star system which is the next nearest star to us or to earth. The light from these stars take 4 years to reach us. So the nearest star is the sun, and the next nearest is the triple star system named Alpha Centauri A, Alpha Centauri B and Proxima Centauri. The light from the sun reaches earth within 8 minutes, but at the same time the light from the next nearest star, the triple star system Alpha Centauri A, B and Proxima Centauri takes 4 years to reach on Earth. So you can compare how far this next nearest star system when compared to the distance between Earth and Sun. Now let's discuss about some of the general aspects of Sun. That is about the size of the Sun. The size of the Sun is (110) times that of Earth. That means if you consider the diameter of Sun is denoted usually represented by a round with a center dot. This is the symbol for Sun. So D, Sun represents the diameter of the Sun is 110 times that of the Earth, the diameter of Earth. Or in terms of radius, we can say that the radius of Sun is also 110 times the radius of Earth. You know the radius of Earth is 6,400 kilometers. So 110 times that of RE means the radius of Sun comes around 6.8 into 10 raised to 8 meters or 6.8 into 10 raised to 5 kilometers, or to get a feeling, it is 68 kilometers. 4 zeros, 1, 2, 3, 4, 5. 6,80,000 kilometers radius. Now if you consider the volume of the Sun, that you can easily calculate from it, that is, if you assume the Sun to be a spherical exactly spherical or a sphere, then the volume will be equal to 4 by 3 pi r cube. You can calculate this volume from this value, and if you put it as volume value of radius of Sun here, then you will get the volume of Sun. If you substitute the radius of Earth here, you will get the volume of Earth. So when you compare the volume of Earth and Sun, you can see that the volume of Sun is 1 by 3 million times that of million means 10 raised to 6 times that of Earth, or which is equal to 4 by 3 times the into 10 raised to 6, or 4 by 3 million times that of volume of Earth. So that much heavier the Sun is. Now if you consider the mass of the Sun is also very high. It is 1 by 3 million times that of Earth. That is, the exact value of mass of Sun is 1.989 into 10 raised to 30 kilograms. If you consider the mass of Sun, it is 1 by 3 million, that is 1 by 3 into 10 raised to 6 times the mass of Earth. The mass of Earth, that is known to you, it is equal to 5.97 into 10 raised to 24 kilograms, and the mass of Sun is 1 by 3 million times that of this value, that you can easily calculate and find to be equal to 1.989, that is approximately 2 into 10 raised to 30 kilograms. So we have discussed about the diameter, the size, the volume and the mass. Now the density of the Sun if you consider, the interesting thing is that the density of sun is less than that of earth. All the thing, that is radius, mass, volume, etc., are much greater than earth, but the density of the sun is less than, and that is 1 by 4 times that of earth. Or the density is little higher than water, that is 1.4 times density of water. So if you represent rho for the density, then the density of sun is 1 by 4 times the density of earth, which is equal to 1.4 times the density of water. So little denser than the water, but much less than 1 by 4, only 25 percentage of density of earth. The reason is that on earth, you know that earth is contains a large quantity of solid materials in the form of sand and rock and dust, but the major constituent of sun, which is a star, is the hydrogen gas. So when compared to the gas and the solid, you know that the density of gas is much less than that of solids. So we can say that density of sun is 1 by 4 times that of earth. The reason is that sun contains a large quantity of gases. It is actually a vast gaseous globe. But at the same time, earth actually contains a large quantity of solid material like sand and rock. That is why earth is a little higher, having a little higher denser, or little denser than, that is 4 times denser than the sun. Now if you consider the surface temperature of sun, you know that the average surface temperature of earth is, we usually take on our area, it is 27 degrees Celsius, but it is comes around, if you take the average all over the surface of earth, it will comes around less than 20 degrees. But if you consider the surface temperature of sun, it is 6000 degrees Celsius. Remember that this is the surface temperature of the sun, but the core of the sun will have a much higher temperature, because the nuclear fusion is the process taking place inside the core of the sun, from where we are getting this enormous quantity of energy. So here, remember that this means 6000, it is an average value, not exact, but average temperature, surface temperature is only 6000 degrees Celsius. But if you consider the core, the center of the sun, temperature of the core of the sun, it comes around 16 million kelvins. That is the temperature needed for nuclear fusion to take place. Now another thing is that the distance between the earth and the sun, which is called the one astronomical unit. So it is a fundamental unit of distance, the distance between the earth and the sun, which is called astronomical unit, AU, which is equal to 1.496 into 10 raised to 11 meters. Usually you can find it as 150 million kilometers. Usually the amateur people use this term 150 million kilometers. The exact value is 1.496 into 10 raised to 11 meters. Here you can see the distance in miles, that is 9 crore 30 lakhs miles, that you can convert from here, that 1 mile is equal to 1.06934 kilometers. It is not needed. If you have any doubts, you can convert this kilometer or meter into miles. You will get this value approximately. Now, another interesting thing is the sun's angular diameter, which subtends about 32 minutes at the earth. That means if you consider a person is standing here on earth and suppose sun is here, then if you consider this angle diameter, this diameter subtends an angle of 32 minutes at the earth. That means half a degree. So that actually represents the angular diameter of the sun from earth. Now another property of the sun is that sun is the only star which shows a disk, and that disk you can see during the solar eclipse. Another thing, being the source of all energy which we use today, is the sun maintains the life on earth. I told you that in the core of the sun, the nuclear fusion is taking place. Enormous quantity of energy has been produced in the form of heat and light while nuclear fusion takes place and is expelled out, and that heat and light is reaching on the surface of earth, and this energy is responsible for the maintenance of life on earth. Also, you can see some of the black spots on the surface of the sun, and by observing the apparent motion of these spots, that is called the sunspot, it is inferred that sun also rotates about its own axis from west to east with a period of 25 days. And also you know that sun is the center of the planet solar system, and all the planets are revolving around the sun, and the gravitational force between the sun and the earth and other planets maintains the planets and including earth to revolve around the sun in an elliptical orbit. Or we can say that it is due to the gravitational attraction of the sun that the earth and other planets move in their respective orbits. And also if you consider the entire quantity of the solar system, almost 99.9% of all materials of the solar system is contained in the sun. Only 0.1% of the entire solar system is there in earth and all other planets, asteroids, comets and meteor showers, etc. all will have only 0.1% of the entire materials of the solar system. Now if you consider the gravity, what we call it as the acceleration due to gravity on the surface of earth, it is 27.9 times that of earth. You know that any object on the surface of the earth will experience a gravity of G is equal to 9.8 meter per second, but on the surface of sun it will be 27.91 times of gravity of earth. Now come back to again into the energy produced by the sun. I told you this radiant energy is generated by the thermonuclear transmutation, which is called the nuclear fusion of hydrogen into helium at a central temperature is about 16 million Kelvin. So at this very high temperature, the 16 million Kelvin provides the sufficient energy to overcome the electromagnetic repulsion between the two nucleuses and to fuse together to form a helium nucleus. So the two hydrogen atoms fuse together to form a helium nucleus, and the defect in the mass defect is converted into energy according to the expression delta mc square and is radiated out. As you know, this sun's total energy output is enormous, and if you make a rough estimate of it, it will comes around 3.85 into 10 raised to 26 joules per second. That is what is called the luminosity of sun. So the luminosity of sun, luminosity actually refers to the amount of total energy emitted per unit time or total energy per unit second. The quantity of energy emitted by an object in 1 second is called the luminosity, and that luminosity of sun is equal to 3.85 into 10 raised to 26 joules per second, which is represented as watt. So 3.85 into 10 raised to 26 watt. So that actually represents the power. The luminosity is nothing but the power, the energy radiated per unit time. Unit time is nothing but unit second or 1 second. So luminosity of an object can be defined as the amount of energy emitted per unit time or per energy radiated in 1 second, which actually represents its brightness, and it is given by 3.85 into 10 raised to 26 watts. Now you know that this much amount of energy will not reach on the surface of earth. If you calculate the amount of sun's energy that falls per second on earth's outer atmosphere, that is represented by another important thing which is called the solar constant, and which is about 1400 watt per meter square or 1400 joules per second per meter square, or in terms of square feet it is 126 watt per square feet. So the solar constant is the amount of sun's energy that falls per second on Earth's outer atmosphere in unit area. So that means if you consider 1 meter square area, suppose this is 1 meter, this is 1 meter, so it is a 1 meter square area, and if you calculate the amount of energy which is reaching on the outer atmosphere of the earth in this area in 1 second will be denoted as the solar constant, and which is equal to 1400 watt per meter square. So the solar constant is the amount of sun's energy that falls per second per unit area on Earth's outer atmosphere, whose value is 1400 watt per meter square. To get an idea of this, what this value is, this is only the quantity of energy from the sun reaching on Earth's outer atmosphere in an area of 1 meter square in 1 second, this energy will be equal to the total energy that is available in a week from all our non-reserves of oil, coal and natural gases. So whatever energy we are using on earth nowadays from all our sources like oil, coal and natural gases, if you calculate the energy used in a 1 week, that will be equal to this value, 1400 watt per meter square. That means the total energy which we are using on the surface of earth nowadays in a week will be provided by sun in a 1 meter square area in 1 second, so that you will understand how much big this value is. 1400 watt per meter square, the solar constant. Now we have to discuss about the structure of the sun, that we will discuss in the next video. Thank you.